So good afternoon and welcome back to the second session, or more precisely to the third session, because in the morning we had covered two sessions, and this session is going to cover for the granular types of bases and also for the waterbound macadam and wet mix macadam. Now, in fact, we are coming to the sub-base course layers, and one of the prominent sub-base course layer which is used is the granular sub-base. As we discussed earlier, that many more options are available, like you have a stabilized soil, you can have a crusher and macadam, but this is the most commonly used sub-base. And even though the word itself is a granular sub-base, the term itself is a entity that it is a type of construction and not simply a type of layer. It is also a type of construction. Granular sub-base is a well-graded material which is laid in one or more layers as sub-base, and popularly it is called as GSB. So in the field they use the term GSB, and when you say GSB it refers to a particular type of construction. Now we'll see that what type of materials we are using in GSB and what are its guidelines or specifications, and how the construction is being affected at the site, and after you do the construction how we are going to check up for the quality. First, let us see the materials. We can use natural sand, muram, gravel, crushed stone, or a combination thereof, crushed slag, crushed concrete, brick metal, laterite, and concrete may also be used. Now once I say, you say that it's natural sand, so natural sand is really not meeting these grading requirement which we are going to see. So it could be a combination of any of the two or more materials. Now when we seek for any material, let us see that what this material should comply, or what are the requirements of this material. The first requirements are those of the grading. Grading, is the particle size distribution of any aggregate or a soil material, and a well graded material means that it has the material available corresponding to each of the sizes from the largest to the smallest size. Now what you are going to see here on the screen is the specifications which were there in the earlier revision 2001. Let me reiterate here that the document which is valid and authentic and legal for highway engineers to be followed in the road construction practices is Specification for Road Works, Road and Bridges Works by MORT&H, Ministry of Road and Transport, and the latest revision is that of 2013, which is being practiced here. But still some of the departments which have older works are still being continued corresponding to the earlier specification. So there is some change but not much. So this is corresponding to 2001 specifications. There are three gradings, and you can see that the sieve sizes range from 75 mm to 75 micron. What is specified is that for grading 1, for example, it should be 100% passing 75 mm. This means that the all particles should be less than 75 mm size. 80 to 100% should be passing 53 mm. This means on the other way around that 0% or maximum of 20% should be retained on 53 mm size. Now all this is actually corresponding to the sieve analysis. So likewise you can see that for each sieve size there is a specified range. For 26.5, 55 to 90, 9.5, 35 to 65, and likewise, and the correspondingly the finer size is 75 micron. So there should be even 3 to 10% of the material finer than 75 micron. 75 micron is 0.075 mm, which is, you know, 0.075 mm is 1,000th of the 75 mm. So means you are going to have particle range smallest to the largest, which is 1,000 times the size. So such being wide variety of the particle size will lead into resulting a very dense mass. Let us see correspondingly the grading requirements for grading 2 and grading 3. In grading 2, the maximum particle size is limited to 53 mm, and likewise for grading 3, the maximum particle size is limited to 26.5 mm. Now if I compare grading 3 with grading 1, you can see that maximum particle size is roughly 3 times in grading 1 compared to that of grading 3, and that of grading 2 is roughly 2 times that of grading 3. But nonetheless, the particle size that should be finer than 75 micron is limited to 3 to 10% in all 3 cases. Now that's a bit interesting. Now that is a grading requirement. What else we want to have from these aggregates? We want to ensure that the CBR value for grading 1 should be 30%, for grading 2 it should be 25%, for grading 3 it should be 20%. Probably these figures may not be seen on the screen, so I repeat, 30%, 25% and 20% respectively for grading 1, 2 and 3. We should have the CBR meeting these requirements. Now remember that when we say CBR value, the CBR value is determined on particle size less than 20 mm. So this means that if we are going to determine the CBR value for grading 1 or 2, you will have to replace the oversized particles with the aggregates less than 20 mm correspondingly. Well, the details I'm not going to talk over here. So now this is what we say for the close graded GSB, close graded. Now in practical consideration, these gradings are very difficult to be made available if we are looking for the natural resources. I'm coming back to the sources slightly later. Let us see the other grading, which is termed as coarse graded. So we have the same sieve sizes, but now the values are specified only for 3 or 4 sieve sizes. So you can see for grading 1, 26.5, other than that it should be all less than 75 mm size. For 26.5, 55 to 75, 4.75, 10 to 30, and for 75 micron less than 10%. So this gives you much more flexibility and leverage because you have to only satisfy 3 to 4 sieve sizes. So it can be very, compared to the close graded, it can be very easily met with. Now if it is so, then do we compromise on the strength? No, we don't, because the CBR value specified or required are same as were for the course, for the close graded. So they remain to be 30%, 25%, 20% respectively. So obviously, somebody could question that, if this material is going to meet my requirement in terms of the strength which I need, so why there's a necessity for going for literally the close graded material? Let me leave for a further discussion. Okay, now in addition, if you see here, we have something like 425 micron material, something 10 to ranging up to 35%, which is lesser than 425 micron. and for that material the liquid limit should be less than 25% and plasticity index should be less than 6%. Now what are these parameters? You know pretty well what are these parameters, but why we need to satisfy them? 425 micron is the size for which you determine the liquid limit values and plasticity index values, right? Now if the liquid limit is higher, the finer portion tends to be on cohesive side, and likewise if plasticity index is higher, the finer portion is again on cohesive side. So if it is goes to cohesive side, it means that the soil, this particular material, is going to have tendency to absorb moisture. As we said in the morning session, that soils which are on cohesive side will have more of the moisture retention capabilities, and we don't want that. That's what we said, that I want my granular sub bases or base courses to be free draining material. So if the fine is not conforming to those requirements, the water retention can take place, and which will be detrimental to the performance of this layer. Now then somebody could ask, why do I then have the finer material at all? 425 micron, what is the necessity of having finer material? Can I do without it? Well, you could do without it, but if it was available like that in the nature, but it is not available like that. So thereby, and secondly, we said that the density will increase if you have the finer portion, because they will fill in the voids, resulting to denser material, and the denser material is going to be more stable. Now, what is the stability? You had talked of CBR value, and now we talked of stability. CBR is the strength parameter, but as we said that due to certain issues in say subgrade, if the undulations take place which will not be conforming to the good performance, so thereby stability of any material is desirable, which would resist those kind of phenomena to be taking place. Okay, what else? Which one to choose, close graded or coarse graded? Obviously close graded is well graded and will result into more dense mass, having higher strength compared to coarse graded GSP. Now if I practically speak of the requirement, then I would rather say that if you are going to build up an expressway or national highway, or say even a state highway, which is going to cater to a very large volume and weights in terms of the traffic requirements, so I would be looking for a well graded material, because I look for a very high performance from that. But if I am going to say build up even a state highway, MDR, ODR, or any other kind of road with not very heavy traffic, so I'm happy to go with the coarse graded material, because that is going to be costing me less and is going to be performing well for the requirements. So close graded or coarse graded, I hope this point is now clear, that which of the grading we will select and what are the implications of their selection. Now there are three grading for each of them, for coarse as well as closed, and then we need to know which one is suitable for what purpose. So grading 1, because it has got the particle of maximum particle size is limited to less than 75 mm, so obviously a larger particle size grading should be used for higher thicknesses, and for lower thicknesses then we can go for smaller particle sizes, which are reflected in grading 2 and grading 3. Now to the next question could be, Can I use two different grading for one layer? Now let me explain before that where we are going to select for grading 2 or grading 3. What really goes about is that we have to first determine the total thickness size requirement of granular subbase or GSB layer. Well, which is determined from the design. Design means, it is based on IRC 37 2012 or earlier IRC 37 2001. So from those consideration, you will first ascertain the thickness of the GSB layer. Now, if it comes to be say 300 mm, can I provide this in a single layer, or I have to go for multiple layers? If it is in multiple layers, then what should be the thicknesses of those layers? Now, arbitrarily, suppose I say that the 300 mm thickness is to be provided, then I could go for two layers of 150 mm thickness each. Now you could ask that why 150 mm, because in the soils we said we'll do for the 300 mm. Yes, for the soils we do for 300 mm, but for granular layers not 300 mm. This is limited to a lesser value. So what we would require is that you have to then ascertain the thicknesses of different layers within the same GSB layer. So I could go for 150 mm each, or could be I could go for 3 layers of 100 mm each, or likewise suppose I have requirement of 250 mm, then I can have 150 mm thickness one layer, 100 mm thickness another layer, or 125 mm into two layers. So possible combinations are there. Now accordingly then you will decide that whether I need to adopt more than one grading in my work, and if it is so done, then we place the grading of larger particle size at the bottom and the grading with smaller particle size above that. So that is a basic rule, that the larger particle size should form the base and smaller particle sizes should go up. Now let us see what really GSB material look like, and there are basically two sources of the GSB material. One is a riverbed site. So if you have visited some hill or a river, you must have seen particularly under the bridges that there are some राउंडेड और सेमी राउंडेड बोल्डर पत्थर और साथ में कुछ थोड़ा बारीक मटेरियल और साथ में सैंड है. तो ये रिवर साइड के ऊपर आपको बहुत जगह पे अवेलेबल है, मिल जाता है, बहुत जगह पे बैन है, बहुत जगह पे इसके चार्जेस हैं, कुछ लोग चोरी कर लेते हैं. सो ऑल काइंड ऑफ थिंग्स आर डन. तो दिस इज ए नेचुरली अवेलेबल मटेरियल. तो इसमें आपको सैंड भी मिलेगी और थोड़ा बड़ा पत्थर भी मिलेगा, और ये जो पत्थर होगा ये राउंडेड शेप में होगा. So what you need to do is you have to separate out the oversized material. So oversized material मतलब अगर आप ग्रेडिंग 1 की रिक्वायरमेंट से देखना चाहते हैं तो 75 mm से जितना भी ओवरसाइज है उसको आप सेपरेट कर लें थ्रू सीविंग और अदर प्रोसेस, एंड देन यू कैन फाइंड आउट द ग्रेडिंग एंड सी इफ इट मीट्स योर रिक्वायरमेंट्स. अब इसकी जो लुक्स हैं वो बड़ी डिसेप्टिव होती हैं कई बारी इन स्टॉक पाइल. कभी कभी आपको क्या होगा, जैसे ये स्टॉक पाइल एक कर दिया और बारिश आ गई तो आप देखोगे कि आपको खाली ऊपर पत्थर नजर आएगा, तो मिट्टी नजर नहीं आएगी, मिट्टी या सैंड नजर नहीं आएगी क्योंकि वो थोड़ा वॉश आउट हो जाती है. सो दिस विल गिव यू अ डिसेप्टिव लुक कि ये खाली पत्थर ही है. तो ये आपको कसी मार के प्रैक्टिकली या जेसीबी लगा के आप देखेंगे तो तब आपको इस तरह से मटेरियल नजर आएगा, तो आपको समझ आएगी कि इसमें बारीक सैंड साइज भी अवेलेबल है. ये एक नेचुरली अकरिंग मटेरियल है. देन द सेकंड, अगर इसको हम थोड़ा क्लोजली देखें, अब ये पिक्चर में हमने ये दिखाया हुआ है कि इसमें बड़े साइज से लेके छोटे साइज तक हमने दिखाया हुआ है, तो इससे आपको रेंज ऑफ पार्टिकल साइज समझ आएगी। वही मटेरियल है, इसको अगर मैं सीविंग करता हूं और छोटी सीव से लेके स्टॉक पाइल करता हूं बड़ी सीव तक साइज के, तो इस तरह से आपको नजर आएगा कि बारीक होता 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 और ऊपर वो मोटा मटेरियल तक नजर आता है। So this gives you an indication what is the range of particle size here. Okay. Now this is what it would look like. जो आपका river bed पे material है, some stones and finer wet mix sand and grit which you can see. Now if you do the grading check and you find out that the material does not meet your requirement, so what you are going to do, there is a second source of granular sub-base material and that is the quarries. क्वेरीज यानी कि खनन जहाँ किया जाता है पहाड़ों को तोड़ के या पहाड़ों के नीचे से। बहुत बार आपने देखा है कि ब्लास्टिंग से पहाड़ तोड़ते हैं तो वो जो मटेरियल आता है दैट कैन बी यूज्ड एज ए जीएसपी मटेरियल। तो अगर आपकी ग्रेडिंग रिक्वायरमेंट मीट नहीं होती तो जो भी उसमें शॉर्टेज है that size of material will have to be blended with your original material and then you need to recheck before you go for the application part. Now let us see how we go with the construction. So before we go for construction, let me recapitulate. There are two sources of GSP material, riverbed side and secondly is the quarries. Or third is now that you need to blend the material from crusher side with some natural material. The second is you need to check the grading. So and you need to select the grading. So grading, there are 6 gradings, 3 close graded and 3 coarse graded depending on the sieve size requirement. Any material first should meet the grading and then you should check the CBR value, that whether the CBR value is as per requirements. अब इसके बाद एक चीज होती है जिसको हम बोलते हैं डिजाइन। जीएसबी का डिजाइन, ग्रेनुलर सब बेस का डिजाइन लेबोरेटरी में क्या करना है, जो भी आपका ग्रेडिंग मटेरियल आया है उसके ऊपर हमने ओएमसी एंड एमडीडी निकालनी है। वी जस्ट नीड टू नो कि कितने इसमें मॉइस्चर चाहिए होगी और कितनी इसकी डेंसिटी आती है, बिकॉज दैट इज द टूल विच इज टू बी यूज फॉर द क्वालिटी कंट्रोल एट द साइट। सो डेंसिटी इज द ओनली मोस्ट प्रोमिनेंट क्वालिटी कंट्रोल tool which is to be used for GSB. Now first आपने मटेरियल को डंपिंग करना है। अब ये जो डंपिंग करना है ये ऐसे नहीं करते, इसको प्लांट वे में डंपिंग किया जाता है। वो कैसे, देखिए अभी आपसे हमने ये कहा कि GSB की से टोटल लेयर है 300 mm। तो अगर आपने ये डिसाइड किया है कि जो बॉटम लेयर है दैट कैन बी से 150 mm, तो एक्चुअली तो लेयर इसकी 175 तक भी जा सकती है बट सपोज आपने 150 mm डिसाइड किया है। नाउ व्हाट यू नीड टू नो इज डिपेंडिंग अपॉन द विड्थ व्हिच इज टू बी कवर्ड एंड थिकनेस, you need to find out the loose quantity of GSB material in per kilometer length or maybe per 100 meter or whatsoever is convenient. तो मान लीजिए पर किलोमीटर में मुझे इसकी लूज क्वांटिटी पता चल गई, तो आपने लेंथ ले लिया, उसका विड्थ ले लिया, मल्टीप्लाई किया तो एरिया आ गया, उसकी थिकनेस से मल्टीप्लाई किया तो वॉल्यूम आ गया, और जो लूज बल्क डेंसिटी से अगर आप मल्टीप्लाई करेंगे तो आपको उसकी रिक्वायरमेंट इन केजी आ जाएगी एंड यू कैन कन्वर्ट इट इन टर्म्स ऑफ द वॉल्यूम। तो अनफॉर्चुनेटली अभी भी फील्ड में वो वेट नहीं, वो क्यूबिक फिट के हिसाब से आपको मटेरियल सप्लाई होता है। तो आपको फिर प्रैक्टिकली अगर आप फील्ड इंजीनियर हैं या हो गए या कभी रहे हैं, तो आपको ट्रक के साइज के हिसाब से रिक्वायरमेंट देनी पड़ती है, क्यूबिक फिट, इतने क्यूबिक फिट चाहिए। तो एनी हाउ एज एन इंजीनियर यू कैन इजीली डू दैट। अब आपको पता होना चाहिए कि आपकी जो गाड़ी है उसमें कितना मटेरियल आता है, एक गाड़ी जो सप्लाई होनी है। तो इसमें जिससे भी सप्लाई होना वो कोई स्टैंडर्ड नहीं होता, देयर आर सम वेरिएशन, सो यू नीड टू नो। अब अगर एक गाड़ी में इतना मटेरियल है तो मेरी रिक्वायरमेंट पर किलोमीटर इतनी है, तो मैं ये कैलकुलेट कर रहा हूँ कि 1 किलोमीटर में इतनी गाड़ियां आपको डंप करानी है। सो एज एन इंजीनियर यू विल टेल योर सुपरवाइजर और वर्क मुंशी कि रात, क्योंकि सप्लाई यहाँ चोरी का काफ़ी काम चलता है, इस मुझे कहना नहीं चाहिए लेकिन प्रैक्टिकली ऐसा ही होता है, थोड़ा इधर उधर से माल आता है। तो रात को मटेरियल की सप्लाई होती है, बहुत जगह सिटीज एरियाज में ट्रैफिक भी बंद होता है कमर्शियल, तो आपको वर्क मुंशी या उसको बताना पड़ेगा भी गाड़ी वाले से इतने इतने मीटर पे माल गिरवा लेना। तो ये आपको विद सर्टेन स्पेसिंग डंपिंग आपको करवाना है। फर्स्ट स्टेप डंपिंग इज टू बी डन। सेकंड देन जैसा हमने सुबह डिस्कस किया था उसमें स्प्रेडिंग आउट। सो स्प्रेडिंग आउट इज डन with the dozer. So you need to spread out with the dozer, giving a slope and width, controlling the width of the spread. तो उसको आप loosely spread उसको कर लेंगे। So this is the action you can see कि जो excess material है वो side में चले जाएगा। और ये जो पिक्चर में देख रहे हैं एक्चुअली अभी 1 लेन की हम जीएसबी कर रहे हैं, तो वो जो मटेरियल उधर गिर गया है उसको हम उठाएंगे नहीं, इट कैन बी यूज्ड बिकॉज सेकंड लेन में अभी काम होना है, राइट। सो द स्प्रेडिंग आउट ऑफ जीएसबी इन थिकनेस, अब इसमें जो थिकनेस है रफली 25 से 30% एक्स्ट्रा डाली जाती है कंपेयर टू the compacted thickness. So if you say that I have to lay compacted thickness of 150 mm, so I roughly add 30% extra 45 mm, and then I say that loose thickness should be 195 mm. So that's a rough rule, but once you do one construction, so you will come to be precise number what is to be done. So after you spread the material, then we need to sprinkle the water. Sprinkling of water is done with the tanker or with the it is done with the sprinkler. The tanker has a sprinkler fitted at the rear side, and just you move this tanker and allow the water to flow. The approximate requirement for GSB is around 6% of the water. So, but it is very difficult to control in the site. So the site engineers usually by visual observation, by their experiences, they are able to tell that whether the water is sufficient or no. But the good thing in GSB construction is that if you have excessive water going into that, so it will quickly evaporate because it doesn't keep the water absorbed with itself. But excessive water is damaging to the subgrade, so we really don't go for the excessive water. So once you have the water sprinkled, so we will use the vibratory rollers here, and which you saw in the morning session. So vibratory roller, with the vibratory roller we can compact up to 175 or up to even 225 mm of the thicknesses, even though we don't recommend to go for very high thicknesses, but if it is in some cases it's so required that you need to place in a single layer. So with a very good compaction, if you are having a double wheel vibratory roller, so you can easily go for that, but normally we restrict a single layer thickness to 175 mm. If the vibratory roller is not used, then the layer thickness has to be less than 125 mm. But nowadays most of the agencies, construction agencies and contractors, they have the vibratory roller, so that's not a very big issue, because they want to save on actually the number of movements. So if you are able to lay on higher thickness, so instead of 3 layers, you can complete the work in 2 layers with less number of passes. Now, next construction is water-bound macadam, and here this is going to be the next layer other than the granular sub base. Now we are coming to the base course layer. So WBM is a base course layer, and let us see what are the materials here. We have the coarse aggregates, which can be crushed or broken stone. It can be crushed slag, overburnt brick aggregate, or any other suitably occurring material, naturally or otherwise, which can actually meet your grading and other strength requirements. For base course applications, but we look only that it should be only crushed or broken stone, and if you are going to use crushed slag, it should have a density of 11.2 kilonewton per meter cube, that is 1.12 gram per cc. So that's the option given to actually use the waste material, but mostly we use the crushed or broken stone. This is mechanically interlocked and bonded together with the screenings to serve as a base or sub-base course. Now when we say sub-base oblique base course, this implies that in some type of very high quality roads, WBM or water-bound macadam at its best can work as a sub-base, but in case of slightly less important roads, it can work as a even base course also. The sizes of screenings are not given here. To go for another presentation. So there are 6 gradings. I'm not sure whether these are visible on your screen because they are contained in a smaller size. The only difference is, they have 1, 2, 3, 4, 5, and 6. As you remember, we spoke that there are 3 coarse graded and 3 close graded. Now all of, to remove the confusion which was earlier occurring, actually the engineers would refer to them G1, G2, G3, and sometime what would happen that without specifying whether it's a close graded or coarse graded, they will say G1, G2, G3. So to remove that difficulty, now there is only one specification which is said to be 1, 2, 3, 4, 5, and 6, and out of these 6, grading 3 and grading 4, they correspond primarily to coarse graded material, which was earlier there as number 2 and 3 for the coarse graded material, and the other are more or less close graded materials. Now further specifications say that grading 3 and 4 shall be used preferably in lower sub base. What do we mean by lower sub base? As we said that if the sub base consists of more than one layer, the lower layer is termed as lower sub base. So there we will use grading 3 and 4, and in certain cases when we require drainage layer specially, then we can use grading 5 and 6, but grading 5 and 6 is used as a sub base cum drainage layer. So if I have a sub base layer comprised of 2 parts, so lower part shall be made of grading 3 and 4, and upper part shall be of grading 5 and 6. Now the constructional requirement also require for the GSB that the mixing should be done mechanically, but if the job is small size job, then it can be done manually. What is a small size job? For example, you are going to widen a road by say just 1 meter. So that's not really gives you much chance to go for machinery like grader, etc. So in such case, then you can go for a manual mixing. But nonetheless, the objective of avoiding the segregation of particle should be taken care of. Then the moisture content of loose material should be in the range of -2% to +1% of OMC. Optimum moisture content, which we discussed and we determined in the laboratory. So -2% means less than the actual one, and +1 more than higher. Now this is also needed dependent on the environmental conditions. Say if you are going to do work in summer this month, so I need to add extra moisture, because by the time you mix up the material, you go for spreading it out and compaction, lot much moisture would have evaporated. So I'll add something 1% or 1.5% extra water to account for that, so that when I do these operations, my material is in workable condition, and when I do the compaction, I get water corresponding to the OMC values. The rolling can be done for up to 100 mm thickness if you are using a smooth wheel roller, which is of 80 to 100 kilonewton weight, that is 8 to 10 ton roller, which we said in the morning that the very old and conventional roller, yellow colored, which you see everywhere. But if you are going to use a vibratory roller, then you can go for a thickness of up to 200 mm. So you can double the layer thickness simply by using a vibratory roller, and with the same static weight, 80 to 100 kilonewton. But most of the time, as you said, that we do not do the compaction in higher thicknesses, so generally we limit for 125 to 150 mm, and compaction should be done from lower to upper side, as we said, in the longitudinal manner, and with an overlap of 1/3 of the width of the track. That should be done. So you have to start from the one side, give an overlap, when you come back and repeat longitudinally, and this way you cover the whole width, and again do that. Now we come to the waterbound macadam, and these are the grading requirements. Now let me again here reiterate that there are small differences in the specifications which were given in 2001 and in 2012. Earlier there were 3 grading requirements or 3 grading specified. Now they are limited to 2 based on the availability of material. The earlier grading included some grading which was even up to 90 mm size, but now the largest size has been changed and only it's limited to maximum particle size of 63 mm. Now grading 1 is said to be of 45 mm to 63 mm. So this has all particle size passing through 75 mm, and all is retained on 11.2 mm. Likewise, grading 2 has 53 mm passing and 22.4 mm. So this has got all material passing through 63 mm, but up to 5% material can be passing 11.2 mm size. Now obviously we say that as larger is the particle size or aggregate size, you can place the material in the larger thicknesses. Now in addition to one of the grading, you need a screening. So screening, 2 categories of screenings are there. They are classified or termed as screening A and screening B. The screening A is of larger size and the particle size maximum is 13.2 mm, and screening which is classified as B has a particle size maximum 11.2 mm. Now honestly, when you say screening, screening is not a powder or fine material. If you see 13.2 mm or 11.2 mm, it's a kind of fine aggregate. It's again a fine aggregate and not a very sand or very small size of the grit or other kind of material. The gradings for 13.2 mm as well as 11.2 mm is shown over the table. You just need to have three sizes in addition to the highest size, that is 11.2, 5.6 and 180 micron for screening A, and 9.5, 5.6 and 180 micron for screening B. So the larger size screening, that is screening A, will be used in conjunction with the coarser material that is corresponding to grading 1, and screening designated B of 11.2 mm size, they will be used in grading 2 where the aggregate size is lesser. But for economy reason, if you are going to use the screenings of gravel or muram, then this grading is not binding. And in all cases, we have to ensure that the screenings, if you are going to use for muram or kankar, they should conform to the liquid limit and plasticity index requirement. In the similar fashion, we talked of the GSP, and here the liquid limit should be less than 20 and PA should be less than 6 for the material, and fraction passing 75 micron should not be exceeding 10%. So this means that before you actually start the work, you need to take a stockpile of these material at the site. The stockpile would consist of the aggregate as well as the screenings. The aggregate which we are going to use, if you remember, for GSP we talked of CBR value, but here we are talking of the aggregate, so the aggregate properties are slightly different. So here we find out abrasion value, impact value, and flakiness and elongation index, and the coarse aggregate should meet the requirements which are given in the table. Abrasion value should be less than 40%. By abrasion value I am referring to Los Angeles abrasion value, and by impact value should be less than 30%. Now remember, both Los Angeles abrasion value and impact value, they are measure of the strength. So only one of these tests need to be conducted and complied upon, but if you wish to do both, it's your choice. And for the sake that they can be compacted well, the parameters of elongation and flakiness have to be kept within control, and the combined values of them should not exceed 35%. So you will have to certify that the aggregate meets this requirement, the fine material meets the requirements of plasticity index and liquid limit. Now I need to know that how much is the quantity of screenings which is required by me. So depending on the compacted thickness, you can compact the waterbound macadam generally in two thicknesses. One is 75 mm and second is 100 mm. In some exceptional circumstances, if it is so required, you could go for a smaller thickness, but normally it is not done because the total thickness requirement of WBM range from something like 150 mm to 250 mm or 300 mm. So if I say if you have 300 mm, so I can place 3 layers of 100 mm each. If you have 225 mm thickness, 3 layers each of 75 mm. But if you have something like 250, then I can have 1 layer of 100 mm and 2 layer of 75 mm each. So in this manner, you can always actually decide the thickness to be of the layer to be 75 or 100 mm. Now if somebody asks me that if the thickness is 285, well, it is not like that, generally not like that. It usually comes in the differences of 50 mm. But if in any case, if you by certain constraints are there, then we can do the adjustments. So what we need to do is that we need to spread the aggregate from the stockpile using a mechanical spreader or a template, and thickness should be higher than the compacted thickness. Now this is more or less uh, a manual cum mechanical type of the work where the aggregate is spread out mechanically, but then the screenings are applied manually. How we do that? First we spread the aggregate just like we showed you in the GSP material. Now we compact it partially. Remember, I am saying it partially, not fully. भाई पूरा कंपैक्ट नहीं करना है, थोड़ा ही करना है. थोड़ा कंपैक्ट करने का मतलब है जो आपने उसको बिछाया है उसको आप एक बारी सेट कर दो, थोड़ा सा हल्का कंपैक्ट कर दो. अब क्योंकि ये जो मटेरियल आपने बिछाया है ये अभी एग्रीगेट ही है, तो इसके अंदर काफी वॉइड्स हैं, स्पेसिस हैं, तो उसको फिल करने के लिए हमें स्क्रीनिंग्स लगानी है. तो इसीलिए उसको हमने फुल्ली कंपैक्ट नहीं किया है. तो अब हम इसके ऊपर स्क्रीनिंग्स लगाएंगे और स्क्रीनिंग्स को हम मैनुअली ही लगाते हैं. तो स्क्रीनिंग्स को टोकरी में भर के उसको स्प्रेड आउट कर देते हैं. आपने देखा होगा, इट इज जस्ट स्प्रेड आउट लाइक दैट. ये किसी ग्रेडर या उससे स्क्रीनिंग्स नहीं लगाई जाती, ये मैनुअली ही लगाई जाती हैं. एंड यू हैव टू जस्ट विजुअली एंश्योर के द स्क्रीनिंग्स आर स्प्रेड आउट इवनली. तो अगर आपको जरूरत पड़े तो आप ब्रूमिंग से स्क्रीनिंग्स को डिस्ट्रीब्यूट कर सकते हैं. कहीं ज़्यादा गिर गई तो ब्रूमिंग से उसको दूसरी जगह कर दें जहाँ पे स्क्रीनिंग्स कम है. अब इनको स्क्रीनिंग्स को थोड़ा धीरे धीरे लगाना है ताकि वो जो वॉइड है उसको फिलअप कर दें. और जब आपने स्क्रीनिंग्स एक बार लगा दिया तो फिर उसके ऊपर हल्का स्प्रिंकलिंग ऑफ वाटर करना है और स्वीप एंड रोल, यानी अगर जरूरत पड़े तो हैंड ब्रूम से उसको थोड़ा सा डिस्ट्रीब्यूट करें. फिर थोड़ी और स्क्रीनिंग लगाएं ताकि पूरा एरिया जो है स्क्रीनिंग से कवर हो जाए. देन दोबारा से उसको वेटिंग को और स्वीपिंग को आप रिपीट करें और फिर अब हमने इसको कॉम्पैक्शन करनी है. अब जब हम कहते हैं वाटर बाउंड मैकेडम, तो इसकी मैं आपको पिक्चर थोड़ी देर में दिखाता हूं. अब ये पार्टली मैनुअल है और पार्टली मैकेनिकल है. मैनुअल इन द सेंस जो स्क्रीनिंग एप्लीकेशन है दैट इज मैनुअली डन. The key issue here is the success of water-bound macadam depends on good application of screenings, proper distribution and then the compaction. क्योंकि ये screenings आप ऊपर से apply कर रहे हैं, so in some cases what we do that we apply the screenings, we apply moisture और फिर आप उसको rolling करते हैं. फिर वो स्क्रीनिंग अंदर चलेगी, फिर दोबारा से थोड़ा सा स्क्रीनिंग अप्लाई किया एंड दोबारा से उसको रोलिंग किया. नाउ ड्यूरिंग दिस प्रोसेस व्हाट रियली हैपेंस इज दैट जब ये स्क्रीनिंग्स की रोलिंग होती है तो और इन द प्रेजेंस ऑफ मॉइस्चर ये थोड़ा पाउडर बन जाता है. द पाउडर अलोंग विद वाटर फॉर्म्स ए पेस्ट विच हैज गॉट ए बाइंडिंग प्रॉपर्टी. जितने भी एग्रीगेट्स हैं उसमें सिलिका कार्बोनेट वगैरह प्रेजेंट होते हैं, उनकी जो नेचुरल कंपोजिशन है उसमें सिलिका एंड कार्बोनेट है. एंड इफ यू नो द कंपोजिशन ऑफ सीमेंट, सीमेंट में भी सिलिका और कार्बोनेट प्रेजेंट है. सो द पाउडर ऑफ द एग्रीगेट इटसेल्फ विल एक्ट पार्टली एज ए सीमेंटिंग एजेंट. It may not be very high strength, but it has got a small to moderate strength, so that will help into binding the aggregate together. So that is why we suggest that you just sprinkle small quantities of water, क्योंकि small quantities होगी तभी पेस्ट बनेगा. ज़्यादा होने से वो slurry टाइप बन जाएगा जिसका कि बाइंडिंग इफेक्ट नहीं आएगा. सो वाटर बाउंड मैकेडम की कंस्ट्रक्शन बहुत यूजफुल है if it is done in the controlled manner. But remember the application is by manual, so there why it is time consuming. अगर आपको प्रोजेक्ट को जल्दी खत्म करना है तो वाटर बाउंड मैकेडम जो है वो टाइम कंज्यूमिंग एक्टिविटी है. तो उसका अल्टरनेटिव है वेट मिक्स मैकेडम, WMM, वेट मिक्स मैकेडम. वेट मिक्स मैकेडम is a granular material pre-mixed with water. Pre-mixed with water यानी पहले से ही आप पानी में मिक्स करेंगे उसको साइट पे लाने से पहले. And laid in thickness not less than 75 mm, minimum thickness 75, maximum up to 200 mm. अगर आप वाइब्रेटिंग टाइप कंपैक्शन इक्विपमेंट यूज करते हैं तो तो मटेरियल जो है उसमें यूज करना है आपने 2 फ्रैक्चर्ड फेसेस होने चाहिए। व्हाट डू इट मीन्स फ्रैक्चर्ड फेसेस? जब हम मटेरियल एग्रीगेट को क्रशर में ब्रेक करते हैं तो नेचुरल साइड होती है एक, और एक होती है ब्रोकन साइड। तो ब्रोकन फेसेस मिनिमम 2 होने चाहिए, तभी उसकी इंटरलॉकिंग अच्छी होगी। These are the requirements of the grading. So you will have 53 mm up to 75 micron. इसमें एक ही grading है, कोई confusion नहीं है, single. So maximum particle size is less than 53 mm. और अगर आपका 45 mm भी down है तो भी this material is going to work. So you have also the finer material of 75 micron passing, which is 0 to 8%. And thickness to be laid is 75 mm to 200 mm. Now the aggregates which you are going to use is meeting these strength requirement which we discussed earlier. And let me show you now the construction operations which are, yes, okay. Now this is showing you the dumping of material for the waterborne macadam, and we will then spread it out coarse material, और उसके बाद जो है स्क्रीनिंग अप्लाई करने के बाद फिर थोड़ा सा वाटर स्प्रिंकलिंग करने के बाद उसको कंपैक्शन किया जाएगा। सो यू कैन सी हियर दैट द सम स्लरी फॉर्मेशन टेक्स प्लेस। वो स्लरी फॉर्मेशन आपको जो है, अगर आप ड्रम देखेंगे रोलर का, तो वहां पे आपको नजर आएगा कि कुछ मटेरियल स्टिक कर रहा है। Actually, this is what actually the slurry is. So some of the slurry is sticking over here to drum. Now once you do the compaction and allow it to dry, so this become a binding agent. The slurry becomes a binding agent, and the aggregate is very closely bound with each other. और फिर हम अगर इसको वाटर बाउंड मैकेडम को अगर आपने नेक्स्ट लेयर रिसीव करनी है तो इसको रफ फिनिश छोड़ देते हैं। अगर आपने इसके ऊपर ट्रैफिक चलाना है तो थोड़ा सा सैंड या स्टोन डस्ट उसके ऊपर स्प्रिंकलर करके फाइनली आफ्टर ए डे और सो उसको दोबारा से रोलिंग करते हैं। तो देन इट गिव्स यू ए गुड फिनिश, एंड देन यू कैन यूज इट फॉर कैरिंग आउट द ट्रैफिक टेम्परेरीली और फॉर ए लॉन्गर पीरियड. So this is about the WBM. Now about the wet mix macadam, ये कैसे बनाया जाता है? सबसे पहले इसका हमने एक मिक्स डिजाइन तैयार करते हैं. मिक्स डिजाइन में क्या करते हैं, क्योंकि हमें डिफरेंट ग्रेडिंग की डिफरेंट रिक्वायरमेंट है, सो व्हाट वी वुड रिक्वायर इज, और ये मटेरियल रेडिली अवेलेबल नहीं है, इट इज नॉट समथिंग विच इज इजीली अवेलेबल, तो वो आपको खुद ही उसको कहीं बनाना पड़ेगा. तो हम क्या करेंगे, इसमें अलग अलग मटेरियल अवेलेबल लेंगे. यानी अगर मैं क्रशर पे जाता हूँ तो उसको कहूँ भाई मुझे वेट मिक्स मटेरियल का मटेरियल दे दीजिए, तो कहेगा साहब मेरे पास तो 1 इंची है, 1.25 इंची है, आपको जो चाहिए स्टोन डस्ट है वो ले लो. सो एज एन इंजीनियर आप वो सारे मटेरियल को सैंपल लेके उसकी सीमल सी लगा के then you will find the ratio in which that has to be mixed so that you get the desired grading. ये grading जो है फिर हमें स्पेसिफाई करना होता है. और वेट मिक्स प्लांट, जैसे आपने हॉट मिक्स प्लांट सुना है, ऐसे ही वेट मिक्स प्लांट होता है. उसमें बिन्स होते हैं, उसमें डिफरेंट मटेरियल रखे जाते हैं अलग अलग साइज के, फिर वो कंप्यूटर कंट्रोल्ड है, उस पर रेशो दी जाएगी. तो वो मटेरियल सारा मूव होके उस रेशो में आके एक सेंट्रल हॉपर में आता है, उसमें फिर वाटर एडिशन करके हम उसको मिक्स करके फिर ट्रक में या डंपर में कैरी करके साइट के ऊपर उसको ले जाते हैं, एंड देन इट इज स्प्रेड आउट यूजिंग ए पेवर, तो इसके लिए एक पेवर भी आता है अलग से, और अगर पेवर नहीं है तो फिर ग्रेडर से स्प्रेड करके इसको कॉम्पैक्शन की जाती है। अब बहुत बार क्या होता है कि आप मटेरियल को साइट पे ले जाते हैं, आपको वहाँ पे इमीडिएटली कॉम्पैक्शन नहीं होती, so you can allow that to happen, but when you are going to spread it out, you are going to add up more water, so you have to make up for the evaporation losses, but a good quality is ensured when you are using a paver. So that is how then बाकी वही compaction using sprinkling, slight sprinkling and finishing is being done. So this is all about the granular layers, granular type subbases and water-bound macadam and wet mix macadam. So in this session we discussed three of them, WBM, WMM and GSB.